All right, so like I said, this is, I know we don't really have our textbooks, but we still kind of are following our Algebra 2 textbook, but this is section 5.4, dividing polynomials. So the first few kind of examples, we just want to look at some review of dividing different polynomials. And because if you come across an example like one of these simpler ones, you definitely want to do it by the methods I'm showing you here. But if not, we're going to have two methods. One is long division. The other is synthetic division. Long division is definitely the, how do I put it, the harder method of the two, in my opinion. But the nice thing about long division is it works for every problem. Synthetic division is definitely the easier or quicker method, but it has limitations. And I'll explain like when or why you can't use a certain method. But I mean, 99% of the problems when we're doing dividing polynomials, you're going to want to use synthetic division. So but I wanted to show you long division as well, just in case you come across it in a future class. There are some, like I said, there are some problems where you would have to use long division. But before we get too far ahead of ourselves, looking at these review questions, if you're dividing by a monomial or just a single piece, if it's possible, you want to see if you can just divide it to each term on the top. So for example, 6x to the fourth power divided by 3x squared would, well, 6 divided by 3 would be 2. And then when you remember, when you divide like powers, you subtract, like it's kind of like you're canceling out two x's. So you would have x squared because 4 minus 2. Then we would do the next term. So 15 divided by 3 would be 5. 3 x's canceling out 2 x's would just be a single x. And then lastly, 3x squared divided by 3x squared would just be 1. So this would be our answer. And kind of like the idea in the future is like if we can divide our polynomials like this 3x squared would have a solution of 0, and then you can get something like I could factor out this 2x squared minus 5x plus 1. I might be able, I couldn't do grouping, so you'd have to use like quadratic formula or something. So the answers are probably a little bit messy, but this is something you could solve, like now that we've lowered the degrees. How about you guys try question 2 if you want to give that one a shot, see if you can divide this by a monomial. But sometimes this is worth checking. Like, I mean, like if you come across, I'll be honest, I don't know how many problems this will really apply, but if you are in a situation where you can divide it like this, I mean, you definitely would, you'd rather do this than long division or synthetic the situation. But like this one, if you divide it, I mean, first off, 21 divided by 7 would be 3. And then since this is a first power and a first power, basically you're just going to subtract 1 power from each one of the variables. So like that a to the 5th would be a to the 4th, b to the 3rd would be b to the 2nd. Basically, you're canceling out one of those x's. Then 14 divided by 7 would be 2. And then, like I said, basically you're just lowering the power by 1 for both of those variables, because you're really just subtracting 1 from each power when you divide by a and b. And then 63 divided by 7 would be 9. A lowered by 1 power would just be a. And then the b's basically would cancel out. You'd have b to the 0, which is just 1. So this would be your final answer for this one. And honestly, since we have two variables, like, I mean, honestly, this wouldn't really necessarily be something we'd be able to solve anyways. But just kind of like anytime you get like a fraction like this, keep in mind, like, and even like when you're doing like quadratic formula, for example, like keep in mind, like whatever your bottom number is, you really could just divide each piece by it potentially. Sometimes that might make your answer look a little bit nicer, kind of thing. But a lot of people are sending me in the chat. Looks like you guys had it. I probably just cut you off a little bit in terms of time. I believe they're all looking good that are coming in though. But like I said, honestly, these first two examples, I don't know how much they'll come to play, but not a bad thing to see. Another kind of thing is if you're dividing by a binomial, if you can factor your numerator, sometimes you can just cancel out the factors. And we'll see, actually, I believe it's chapter 7. We look at rational functions. It's either chapter 6 or chapter 7. I think it's chapter 7 in the book, though. But we're going to be looking at this concept a little bit more. But this is kind of how a lot of the problems are going to work. Like that top, you could factor. like what multiplies to 10 and adds up to -7, well, that would be w minus 5, w minus 2. So if you notice, one of our factors are the same. So sometimes you can just cancel these out. Like, so, but this only obviously would work if you can factor your numerator. And a lot of times you'll have a power that's like, you won't always have a quadratic on top that's easy to factor. Number 4, I'm just going to kind of do this one quickly. You could do group in. I think it would be, kind of want to just do it without doing the grouping process, but that would be what multiplies to -8 and adds up to -7. Well, that would be -8 and +1. I kind of wanted to just, there. So sorry, I'm kind of just janking this one. So I'm going to erase this. So I'm just doing the grouping process, but I'm just factoring that top part. So you would do group in. You could also do like a different method if you'd like, but so you can pull out a 4h, and then you can only pull out like a 1. So you really have 4h plus 1, h minus 2, all over h minus 2. So you should see like this could cancel out. So you would just get 4h plus 1, if that makes sense. I know I did this one a little bit quickly, but basically one idea is if you can factor out your numerator, sometimes you'll get a factor that's in common that you could cancel out. And that's not always true. But a lot of time, like I said, we'll see, like this is kind of almost like a preview of like a lot of the problems we'll see in chapter 7, I believe. If whatever I can't remember, whatever chapter is about rational functions in the book, I think it's chapter 7, maybe 8. I'm trying to remember the sequence, but if you can factor out either your numerator or your denominator, sometimes you can find like a common factor between them that cancels out. So keep that in mind. But really the main topics coming up next, we're going to look at long division and synthetic division. So long division, honestly, I'm just showing you it because it works no matter what. But for at least in chapter 5, like every single problem I'm going to give you, you could use synthetic. So that's really going to be our method of choice. But like I said, I want to show you long division just so if you are doing more like advanced problems, maybe in a future course, you've seen this method. So maybe it will come back easier the second time around. And I did put a couple long division questions in Delta Math. We'll see how bad those are, but I threw a couple on just to see if you could do that method as well. All right, but to do long division, you're basically, if you remember way back to doing division as like a kid when you first learned how to divide by like hand. So it's probably been a while since a lot of us have done division by hand, but basically you're gonna put what you're divided by on the outside and what's being divided on the inside of your like division symbol. So the first thing you want to do is always first just ask yourself, what would I have to multiply this by to get 1x squared? Well, so we're really only focusing on that x part. What times x would give me just an x squared? So that would be an x. So if I multiply that binomial by x, I would have x squared plus 8x. Just remember, when we're doing division, we're going to subtract this. So like the x squareds cancel out. But keep in mind, we're subtracting, so that's really going to be 3 minus 8x. So you're actually going to get a negative 5x here. So don't, like, you could either just switch your signs or just kind of remember you're subtracting when you're doing this division process. And then we're just going to bring down the negative 43. So now we want to ask, well, what would I multiply x plus 8 by to get a negative 5x? Well, negative 5 times x would give me that. So if I multiply that out, I would have negative 5x minus 40. And remember, we're going to subtract this. So negative 5x minus negative 5x would cancel out. And then negative 43 minus negative 40 would be negative 3. And this is our, because if you look, there's, well, what could I multiply x plus by x plus 8 to get a -3? Well, there's nothing I could get without creating an additional problem. So this is our remainder. Like once you get to the constants up here, you're done. So we would have a remainder of -3. And I don't have a lot of space. Sometimes I believe in Delta Math, they want you to write it like this. You basically just put your remainder over your denominator, like what you're dividing by. Let me make sure, is that correct? So like because technically that's -3 is still being divided by that x plus 8. We just couldn't simplify it at all. So a lot of times if you have a remainder, you're going to keep it over your divisor, like what you're dividing the problem by. So I believe in Delta Math, this is how they would want you to write your answer if you have a remainder. So like whatever you have is your remainder. Oh, that's a bad color. You're going to put it over like that. Okay, so this is long division. Like I said, honestly, this isn't going to be our method of choice, but if you like long division, I mean, you could do this for any problem. Our second method, so like I said, long division works for every problem. Our second method, synthetic division, only works, so this only works if you're dividing by like x plus a number, like so like x plus 2, x plus 3, or if you have like x minus a. So like for example, if you were dividing by like 2x plus 3, you couldn't do synthetic division. So, or if you were dividing by a trinomial, not a binomial, can't do synthetic division. So synthetic division only works if you're dividing by a binomial. And I mean, there's ways to get around it, but and if you don't have a coefficient with your x. But this is going to be perfect for like how we're going to use this in chapter 5. Like every problem we're going to see, you are going to be dividing by a binomial like in this form. So like I said, for the purpose of this class, synthetic division is going to work for everything we need. But you might be in a future class where you're dividing by things a little bit more complicated, and that's where you would have to use long division. So that's why I'm showing you both of these methods, if that makes any sense. But here's how you do synthetic division. The first thing you do is we need to basically solve this binomial. So like what would be if we were finding our 0 from this binomial? Remember, it's kind of like the opposite, or you would solve x plus 8 equal to 0. So if you solve that binomial, it's -8. And usually we kind of put this like in a little kind of square on its own. And what we're going to do is we're going to write the coefficients of our trinomial or whatever we're dividing by. So I have a coefficient of 1, a coefficient of 3, and a coefficient of -43. So my first number here, I just bring down. So whatever that first coefficient, if it was a 1, a 2, a 3, a 4, a 6, a 20, you're just going to bring it down. Next, what you're going to do is you're going to take your number here, this -8 times 1. Well, that would be -8. And then we're going to add these together. So 3 plus -8 would be -5. And then we're going to kind of repeat that process. -8 times -5 would be +40. And then we're going to add these together. -43 plus 40 would be -3. And then this is our answer. But what happens when you do this division is like in our original problem, this was like an x squared, an x, and a constant. Basically, it goes down. Like this is my x term. So I have 1x. This is my constant. And then your last square is always your remainder. So whatever you have here is your remainder. So, and like I said, you put your remainder over what you're dividing by originally. But basically, when you're doing this synthetic division, your degree drops by 1 for each one of these. So if my first part was an x cubed, like say I started with an x cubed here, well, then this first number would be my x squareds. But we're going to do some more problems. But any questions so far about anything? And I know it's sometimes can be a little bit strange. I'll make sure I post like a video of synthetic division in case you're not getting it from the notes. But once you get the hang of this, it's actually really easy. Like, I mean, it's a very, like once you get the process down, it's very simple. You're just multiplying and adding numbers. So, but like I said, synthetic division won't always work for your divisional needs. But for this class, honestly, you'll be able to use synthetic division pretty much always. Okay. So I'm going to move on. I'm just going to look at some more examples. Um, and for all of these, if you look at what we're dividing by, they're all binomials with like no coefficients with the variable. So I'm going to do synthetic division for the rest of my examples, just because honestly, that's the method you're going to be using pretty much always in this class. Like I said, I did put a couple questions in Delta Math um, with long division, but um, I'm not as focused on that. And if it's a disaster, I might even take them off. But like I said, in future classes, you probably will you probably will do some long division with polynomials. So if you can get it this year or kind of see how it works, I mean, it'll put maybe a little bit ahead of where you'll find yourself next year kind of thing. All right, so synthetic division, like I said, the key thing is to figure out your like number that you kind of are going to be multiplying by as you kind of do your synthetic division process. You have to solve that binomial. So what would make n minus 7 equal 0? Well, that would be positive 7. So basically, you flip your sign if that's an easier way to think about it. Once you've done that, you're going to write the coefficients of what you're dividing into. This first coefficient, you always just bring it straight down. So to get your next spot, you take your 7 times the 2. That would be 14. Then you add those together. That would be negative 2. And then 7 times negative 2 would be negative 14. So 19 minus 14 would be 5. This last box is always your remainder. So our answer, remember, it lowers your degree each one. So this first box, it's not going to be an n squared. This would just be 2n. Then the next spot would be my constants, minus 2. And then my remainder, which, like I said, you can just put over what you're dividing by. So this would be my answer. And if you did long division, you should see you got the same answer. I didn't really point that out, but you should have noticed this was the same problem, like for question 5 and 6, and we got the same final answer for both of those. So like I said, either method, you should get the same final result. So if you really love long division, I'll be honest, I don't think I've had anyone so far in my honors algebra 2 teaching that have like favored long division. But if that's your bread and butter, I mean, you could do it for every problem. I don't have a problem with that at all. But you definitely want to learn the synthetic division because it honestly, it is faster. It is easier. It's worth learning. Okay, I might do, how about you try this number 8? I'll set it up. So, I mean, if you solve your binomial, that would be positive 2, and then your coefficients would be 1, 5, negative 7, and 2. Oops. So you would bring down your 1. So see if you can kind of do this synthetic division problem. And then see if you could figure out like what would those numbers represent, and just kind of keep in mind it's going to lower, each part's going to lower by a degree. So like your first number, like this is actually going to be a y squared, 1y squared. And then from the rest, and your last number spot is always your remainder. So take a second, see if you can finish this long division process. And like I said, I don't have my key, so I'm going to do it myself here on the side as well. And we'll have to see. I'm pretty sure if I remember right on these notes, all of these problems were getting remainders, but keep in mind if your last spot is a 0, when you finish this, you'll see you don't have a remainder. And that a lot of the problems we're going to be doing in the future, we're going to see like why we intentionally get a remainder of 0. So, but let me know if you guys have any questions as you're going through this. And like I said, I will make sure to find like a good YouTube video kind of going over this process. I said, since I can't see what's going on, it sometimes is a little bit harder for me to judge. But like, so if you're finished this, if you're doing this synthetic process, remember, you're going to take your 2 times this 1. So that 2 times 1 would be 2. So that's what you're going to put there. Then you're going to add this column together. So 5 plus 2 is 7. So then keep the process going. You're going to take this 2 times this 7 we just got. So that would be 14. Then we're going to add this column. -7 plus 14 would be +7. And then do the same thing. 2 times 7, once again, would be 14. And then 2 plus 14 would be 16. So remember, like from your original, each one of these is losing a degree because we're dividing by a y basically. So like each one's losing a power. So this, our first spot would be 1y squared plus 7y plus 7. And then this, like I said, this last number spot is always your remainder. And a lot of problems we're going to see, we're going to get 0 there. So if you ever get 0 in that last spot, it means you don't have a remainder. But since we have a remainder, you just add it and put it over what you divided by originally. Okay, question 9 and 10 are definitely examples we want to be careful about. If you're missing like one of your degree parts, like if you look at number 9, we have a third power, then like just a first power, and then a constant. If you like, see how we're missing that k squared part? If you're missing a part, like one of your powers or your degrees, you need to put a placeholder for it. So like, so in question 9, I mean, you're going to be really, your -5 is going to be kind of what you put in this little squared kind of the start, like what would make k plus 5 equal 0. But our coefficients, my k to the third power is 1. Since I don't have a k to the second power, I have to put a 0 in its place. And then my k to the first would be -17. Then my constants is 32. So like, I'm going to erase this because it's probably too much, but like, see how this was my k to the third, my k squared, my k, and then my constant. So if you're missing one of like your terms, like you just don't have one, you need to put a 0 in its place. So if it jumps to like k to the fourth to k to the second, well, you have to put a 0 in place of that k to the third, if that makes sense. But then, I mean, from here, you just do your synthetic division, like, I mean, normal. But if you don't do this, you're going to get the wrong answer because you're going to be missing part of your like equation. This is also true for long division, actually. Like I said, if you're missing a part in your long division, you do want to put a placeholder. Maybe I'll show you that before we leave, or if it comes up. But you do want to make sure, whatever method you're using, you got to put these placeholders. But so if we do our synthetic, -5 times 1 would be -5. Add that, that would be -5. -5 times -5 would be +25. So if you add that together, you would get +8. And then if you multiply that, that would be -40. If you add that, you would get -8. So remember, each degree, it goes down by 1. So this would be 1k squared. 1 sec, sorry, stop writing for a sec. That would be our k spots, so -5k. That would be my constants then. And then this, like I said, your last number spot's going to be a remainder if you have one. So this would be plus -8 over k plus 5. You could also write that as -8, +8 over k plus 5. It's up to you though. So that would be my solution. But notice, I'm sorry if this is too much like going on, but notice like each one of these spots, it lowered by 1 degree. Like that turned into a constant, and that's your remainder. I'm gonna just get rid of that so it's not too much of a eyesore. But just be on the lookout. I'll be honest, I'll have to double check in Delta Math. I don't know how much this happens, but if you're missing one of your like terms, you need to put 0 as like a placeholder for it. So our last example for today, 8 would be what would be the 0 or solution to that x minus 8 spot. There it goes. Then you put your coefficient. So our x to the 4th is 8. Our x cubed is negative 64. And notice there's no x squared, so I got to put a 0. And then my x's would be 3. Then my constants would be negative 28. So then you would just kind of do your synthetic division. So 8 times 8 is 64. So notice we get 0. So 8 times 0 would be 0, which would still be 0. 8 times 0 would still be 0. 3 plus 0 is now 3. 8 times 3 would be 24. So this is our remainder. So I have, remember, it lowers by 1 degree. So this would be 8x cubed. I don't have any x squares. I don't have any x's. This would be my constant spot here. And then my remainder, put it over what you're dividing by.